about 6.6. So then I thought that we would look through a problem in 6.6. So let me share my screen with you and we'll get started. So our example here is it's an example out of 6.6. So that's using a normal distribution to approximate a binomial distribution. Looks like there's a typo there, so let me fix that. Anyway, so this is the problem itself. Ocean fishing for billfish is very popular in a certain region of Mexico. In this region, about 40% of strikes resulted in a catch. So about 40% of the time that a fish strikes the bait, you actually pull the fish in as a catch. Suppose that on a given day, a fleet of fishing boats got a total of 25 strikes. Find the following probabilities. Round your answer to 4 decimal places. And the probabilities are, we're going to know what's the probability that 12 or fewer fish are caught, 5 or more fish are caught, or between 5 and 12 fish are caught. I think the biggest problem here comes with using salt. So we will do this using salt. So we have to have N, which is our number of our problem, and that is 25 strikes. And our probability of success, which is P, is 0.40 because it says about 40% of the strikes resulted in a catch. So you can see that, and I usually highlight these in my problem. You can do the same. Q is equal to 1 minus P, so 1 minus 0.40 gives us 0.60. You can do that on your calculator if you need to. The mean for our normal distribution is N times P. So let me grab my calculator. And so it's going to be 25 times 0.4. I had a calculator here somewhere. Here you go. 25 times 0.4. And that's equal to 10. So I'm going to come back there and put that on my sheet. So the mean is 10, and the standard deviation is the square root of N times P times Q. So N times P, and then is already 10, times Q is 0.6 was Q on that sheet, if you look at that. And then we need to take the square root of that. So the square root of 6 is going to be our answer for that, 2.4495. 2.4495. 2.4495 is our standard deviation. So again, you get N and P out of the problem, you compute Q, you compute the mean, and you compute the standard deviation. You need to remember that in this section, when we're going to use the Norman distribution to approximate a binomial distribution, so we have to compute the area under the bars. And in order to do the area under the bars, we're going to have to extend that out a negative 0.5 and a positive 0.5 from where we are to get the whole bar under there. And that's called making a continuity correction. If you need to view more on about a continuity correction, please see our textbook for that. Okay, that being said, I'm ready to use salt. So if you can do this and go use salt, then you should be good to go. Okay, so we're a normal distribution. Our mean is 10. Our standard deviation is 2.4495. And we want to know the probability that 12 or fewer fish were caught. Okay, so let's say this bar right here is on the 12 line. To catch everything with the continuity correction in there to get that whole bar, because remember the bars extend from a little bit on each side of 12, then we need to get everything less than or equal to 12.5. Instead of just 12. Okay, so that may be where the problems were coming in for some people. So you want to make sure of that. Get back to here. Whoop. So that standard deviation again was 2.4495. All right. Again, since we have the bar there and this is 12, we have to use 12.5 to encompass everything below 12 or fewer. So that's 12.5. Less than or equal to 12.5. Since it's a less than or equal to problem, let me pull this out for us so we can see the whole thing. We're looking for left tail because we're looking for everything less than or equal to 0.5. Do you know why this is not letting me expand this? There we go. Okay, so it's left tail because we need everything in the yellow to be below 12.5. Make sure you have 12.5 in here, not 5, and then this is your answer. So the probability that we would catch 12 or fewer fish is 0.84628, and we want to round that to 4 decimal places, so 8463. Great. Okay, 5 or more fish are caught. So if this is the 5 and we want everything to the right of 5, we really need everything to the right of 4.5 so that we encompass the 5. So we need everything to the right. So it's a right tail greater than or equal to 4.5 to encompass that 5. And then our answer is this right here. And I'm going to put that on our sheet here. So 5 or more means you need to be using the 4.5 or greater than. Okay. And that gives us a probability of 0.9, which we need to round that to 4 decimal places, so be careful rounding. That 3 does not round the 6 up, so our answer is simply this. Okay, and then the last question says between 5 and 12 fish were caught. Again, we need to use the 4 greater than 4.5 to encompass the 5, and we need to use greater or less than the 12.5 to encompass the 12 here. So this is your 12, this is your 5. You have to be a little on the left side of the 5 to incorporate that 5, then the actual number 5, and then a little bit on the right side of 12 to incorporate the 12.5. So now I'm going to go click the between, and I'm putting in, what was that, 4.5 and 12.5 to get our answer of 0.83391. So the probability equals 0.83391, which when we round to 4 decimals, we just take the 1 off there. So 0.8339 is what you should put in for your answer. So I hope that helps you understand a little bit more of how to work the problems of using a normal distribution to approximate a binomial distribution. And do not forget about the continuity correction that you must make. And again, if you need more instruction on the continuity correction, then you can go to our textbook for that.